Hello friends, this is Durga again from IT Varsity, a one-stop shop to learn all the technologies. At this time we are talking about setting up MapReduce Classic on Cloudera distribution of Hadoop using 7 nodes in AWS. And as part of this video, I will actually explain how the communication between job tracker and task tracker works. It uses something called heartbeat. So at regular intervals, task tracker sends heartbeat to the job tracker to say it is alive, and also as part of the heartbeat, task trackers send the resource utilization by each of the task tracker or by each of the nodes on which task trackers are running. So heartbeat is the communication mechanism between the task trackers and job tracker, using which job tracker can keep track of live task trackers and also the load on the task tracker, and using that information it will actually submit the jobs. So just remember, it is very important about this buzzword heartbeat. Just remember this one, that heartbeat will be used to communicate between the slaves, which are task trackers, to job tracker. And now we will actually understand the MapReduce job flow, how it works. So earlier when I run the job as part of the last video, you can see that I ran a command Hadoop jar blah 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 .jar file, random text writer, and the output path. And from where I have ran it from 242, node 242. And here you can see, even in the picture, it is saying client node. So in our case, 242 is the client or gateway node. So sometimes in some places they might refer it as gateway. Gateway and client are one and same. So here we have submitted the MapReduce job on from 242, which is nothing but a client or gateway node. So once the job is submitted using jar file, we are invoking a MapReduce program. Here you can see Hadoop jar file name, and random text writer. And random text writer actually maps to a Java program. Here you can see random text writer. Okay, and that is the program which we are trying to run. So when it is submitted, so when you hit enter, we are asking to run the job. The first thing it will do is it will get a new job ID, and you can see it here. So after running Hadoop jar command, we got the job ID over here. Okay, once the job ID is received, the third step is to copy job resources. So what is job resources? Job resources for this example is nothing but the jar file, and you can pass more stuff also as part of the job resources, like third-party jar files, some files which needs to be spread across all the nodes in the cluster while running, which is called as distributed cache. All those things also can be passed using various options under Hadoop jar command, which is not which you don't need to worry at this time. Make sure that anything apart from the input path and output path when you run the program as part of Hadoop jar is considered to be job resources. So in this case, job resource is nothing but the jar file which have the application which we are trying to run. So that job resources, once the job ID is received, first thing it will do is client will copy the job resources to multiple nodes in the cluster, and where it will copy to, it will copy to HDFS, and by default it will have 10 copies. If you have 100 nodes in a cluster, these job resources will be distributed onto 10 nodes, and the parameter which will control that is, if you go to MapReduce service, so I am disabling the Foxy proxy because I think here it got disconnected. You can see the broken pipe here. That's where the tunneling is not going on, and Foxy proxy is not working. Anyway, I disabled it now, and now it will work. So go to configuration, and there will be a parameter for cache in MapReduce. So it is running very slow. Anyway, let me go here. So once you get into the configuration, you can search for cache. I hope it will return. No, it is not. So I think it will use this MapReduce local dir only. So if you go here and if you look into this one, okay, find name training.jar. Anyway, I think it is flushed out. Somewhere it will be saved. Using some location in HDFS. Yeah, actually it will be in HDFS. So it should be under Hadoop FS ls / tmp. Okay, I think it is already flushed out of HDFS. So anyway, it will store somewhere in HDFS, and by default it uses 10 copies of that jar file in HDFS, and once the copy is done, it will actually issue the submit job. Once the submit job is done, it will actually start initializing the job. Once the job is initialized, what job tracker will do is it will talk to the name node and try to get the input path. If the input path is provided as parameter, the job tracker will talk to name node and determine where the blocks of that file is. Because when you actually submit the MapReduce jobs, it has to use data locality as much as possible and run the mapper tasks on the same nodes where the data exists. So job tracker has to know where the blocks related to that file are, and it has to retrieve that information, and then using that information, it will actually on top of that, it will also check the health condition of each of the nodes by getting heartbeat from the task tracker. Using the information of input splits and the health status of task tracker, it will talk to the task tracker on which the data is existing and try to create the JVMs to invoke map task or reduce task. And when the JVM is being invoked, task tracker actually copy the resources from the shared file system into the map task or reduce task JVM, and that as part of the job resources, you will get the code, and that code will be used to process the data. So if you keenly observe, we have submitted the code on the client node, but the same code is copied in the form of job resources to HDFS first and then to the JVM which is actually processing the data. And where this JVM will be executed, especially for map tasks, those JVMs will be typically on the same hosts where the blocks related to that input data is. So that is called as data locality. Okay. Now using this code in child JVM for each of the map or reduce tasks, it will actually process the data and the output will be finally stored in output path if it is required. So this is how MapReduce job will be executed. And also you need to understand the fault tolerance, which I will be covering as part of the next video. That being said, if you like this video, please click on the like button. If you want to provide the feedback, please use the comment section of the video. If you want to discuss further about big data or Hadoop, please join my LinkedIn group called ITversity-Big Data or ITversity sorry, for both big data and Hadoop, the LinkedIn group is called as itversity-big data, and for certifications it is itversity-certifications. And finally, if you are not subscribed to my channel yet, please do so. And also, if you live in the countries where the fan funding or support this channel is available, it will be visible over here. You can go there and you can actually start supporting my channel so that I can come with more and more content like this over time. Thank you. Bye.